Hi everybody, I'm Jim Siegels for Space Insights. As you can see, I'm wearing my COVID-19 mask here, and we're at the Cape Canaveral Air Force Station. Behind me is Space Launch Complex 41, and that's an Atlas V rocket on the launch pad. My media colleagues and I are setting up remote cameras for a launch tomorrow of a mission called United States Space Force No. 7. Here's where the Space Launch Complex is located, and here's a shot of the Atlas V rocket being transported to the launch pad a few days ago. What's inside that fairing at the top of the rocket? No, it's not a satellite. It's a space plane, a highly classified, reusable, robotic spacecraft called the X-37B. Yes, the 27-foot-long, 11,000-pound spacecraft is nestled inside the fairing. Here's some drawings to give you various views of that spacecraft. I like to think of it as a kind of mini space shuttle, propelled by a rocket into low Earth orbit, and it returns under its own power to land on a runway. Again, just like the shuttle. The X-37B is about a fourth the size of the shuttle, but it has no windshield. Why? It's robotic. There's no one inside. Let's take a look at a brief video provided by United Launch Alliance of what the launch is likely to look like tomorrow morning.
And liftoff of the United Launch Alliance Atlas V rocket.
The Atlas V RD-180 engine ignites and generates 3.83 meganewtons, or 860,200 pounds of thrust, to lift the rocket away from the pad. Shortly after liftoff, Atlas begins a pitchover to attain the proper flight path, while minimizing the pressure the vehicle experiences during flight. Within the first couple minutes of flight, the Atlas V reaches Mach 1, the speed of sound. Approaching payload fairing jettison, the Atlas V is burning propellant at a rate of 719 kilograms, or 1,585 pounds per second, traveling more than 9,500 kilometers, or 5,900 miles per hour, and located 112 kilometers, or 69 miles in altitude, and 116 kilometers, or 72 miles downrange. During ascent, the X-37B orbital test vehicle is protected inside a 5-meter diameter payload fairing. This two-piece shell encapsulates both the Centaur upper stage and the X-37B. Once the vehicle is climbed above the densest part of Earth's atmosphere, the payload fairing is jettisoned. Following jettison of the payload fairing, propellant levels deplete and the booster engine shuts down. Following booster engine cutoff, the Atlas Centaur separation system activates to release the booster stage. The vehicle now weighs a little more than 15% of what it did at liftoff. The Centaur main engine is then started to begin second stage flight. Following main engine start, Centaur continues on to deliver the X-37B to begin its classified mission.
In a show of national solidarity, this mission is dedicated to honor frontline responders and those affected by COVID-19 pandemic. Even though most of its mission is classified, we do know about a few secondary investigations aboard. First, a reaction of certain materials to space radiation. Secondly, measuring the effect of ambient space radiation on seed growth. Next, transmission of radio frequency microwave energy to Earth. And fourth, release of a small satellite called FalconSat 8. No, that does not refer to the SpaceX Falcon 9 rocket. Rather, it refers to the mascot of the Air Force Academy. The satellite was designed and built by Air Force Academy cadets in partnership with the Air Force Research Laboratory, and will reportedly have 5 experiment payloads on this satellite. The prior X-37B mission returned last October after spending a record 780 days in space. No word when this one will return, but here's how to find out. Bookmark this website, nasatech.net. That's NASATECH.net for unsurpassed coverage of American space programs. We'll be back tomorrow to cover the United States Space Force 7 Mission launch. For Space Insights, this is Jim Siegel, signing off for now. So long.